We're going to look at using some identities to simplify these expressions. So looking at the first one here, number 1, I noticed that I have a half angle here. So I'm going to make use of the identity cosine of x over 2 is equal to the square root of 1 plus cosine x over 2. Okay, so I'm going to substitute that in there. Now remember, that one is squared, so I'm going to have 2 times the square root of 1 plus cosine x over 2 squared minus 1. And, well, would you look at that? I can square the square root and it just goes away. So I have 2 times the quantity, 1 plus cosine x over 2 minus 1. The 2's cross out, and the 1's cross out. So naturally, all of these are equal. So just to emphasize that, yes, that expression is equal to cosine of x. And that is definitely in simplest form. Can't argue with that. Now looking over at number 2 here, this one's a little bit different. We have a difference of fourth powers, and the first thing that strikes me is, it looks like something I used to factor from algebra. Maybe it's something of the form x to the fourth minus y to the fourth. That might make it look a little more familiar. So remember that with differences of squares, we factor, it's basically the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. And I look at those two things and I think, hey, they look familiar. Cosine squared plus sine squared x is 1. And cosine squared minus sine squared, if you look at your list of identities, is just the identity for cosine of 2x. So that means that that complicated expression is really just equal to cosine of 2x. How nice is that? Okay? So moving right along to number 3, notice I'm squaring a binomial. So that means, what's the only thing you can do when you have something squared? Multiply it out, right? So we're going to have sine x plus cosine x and sine x plus cosine x. And then we just FOIL, right? So first times the first is sine squared x. Outwards give you sine x cosine x, and so do the inners. So that's plus 2 sine x cosine x. And then the last times the last is cosine squared x. Now, not quite done, because now notice some things look familiar here. I'm going to regroup here and put the sine squared x and the cosine squared x together. So I'm going to write it like so. And then notice this is just 1. And then this is the identity for sine of 2x. And that is as good as that one's going to get. So that's the answer to that one. Okay, almost there. Number 4. Now, one strategy you might have picked up was, if you see one of the reciprocal functions, immediately write it in terms of sine and cosine. That can work here. But what I'm noticing is that I have a secant squared in the numerator and a secant squared in the denominator. So I'm going to use a slightly different strategy. And remember that when you have a fraction like this, you can split it up. This is this kind of the reverse of subtracting two fractions. And what I am to notice here, secant squared over secant squared is 1. Now, what I am going to do, though, is if I have secant squared in the denominator, that's the same as cosine squared in the numerator. And hey, wait a minute, that should look familiar also. This is one of the 3 identities for cosine of 2x. And that does it for us there. Whoopsie. I meant to change the highlighter, but it doesn't matter anyway. There we go. Okay. Last, but certainly not least, is number 5 here. Now, I have 2 terms that have common factors. So one of the strategies that you might remember is to factor if possible. So I'm going to factor out a 2 sine x cosine x, because that seems to be the common factor between the 2 terms. And let's see what happens when we factor that out. So I'm going to remove the 2 in the sine x, and I remove one of the 3 factors of cosine x. That's a cosine squared x. And from the right-hand side, it looks like I'm left with a minus sine squared x. Well, that looks simplified, doesn't it? And 2 sine x cosine x is sine of 2x. Cosine squared minus sine squared is cosine of 2x. Now that might be a good stopping point for now, but I also noticed something. Remember that sine of 2, and I'm going to call it something else, theta, is 2 sine theta cosine of theta. So if these match, that's the equivalent of saying double the theta, right? Well, one slight weirdness here. I don't have the 2 that goes in front. So what I'm going to do is I'm going to multiply by 1/2 times 2, because that's 1. And, now this whole thing looks like 1/2 sine of, now it's 2 times whatever is there. So that's 4x, and that is the simplest way to write that last one. So number 5 there, a little bit tricky. So hopefully that gives you an idea of how to use the strategies and some definite patterns to look for, especially with those double angle identities. Be sure to check out the other video for that other complicated trig function that we were looking at. And I guess that's it for now. So please keep watching.